Okay, so we're going to go over 3.1, which is called slope-intercept form. Now, of all the forms of an equation, this is probably the one that you will use over and over and over and over again. So I want you to keep in mind a couple of things. Number one, so in my high school classes, all 4 of my high school classes that I teach right now, y equals mx plus b keeps showing up. Okay, so if you can, be comfortable with this equation, be very familiar with it. Whenever you see it, you'll be like, oh, I know this. I know what this means, and I know what this means. So because this is your first interaction with it, don't assume that you have to learn it and be a master of it the very first time. What you're really trying to go for is just familiarize with yourself with it at every single interaction. Okay, so the very first thing is it's a linear function, and the word function we talked about before. The linear part just means that this equation describes a line. And so what I've told my students is before is when you were learning how to read, and you can ask your parents if this happened, but when I was learning how to read, there'd be a word like the word cat, right? And because I didn't know how to read, some of the books that I had would have a small little picture of a cat right on top of it, right? And then this is not looking so cattish, but that's okay. So then my brain would say, oh, that's cat. That looks like a cat. So this word here must mean cat, must say cat. And so my brain got so used to putting these two things together, that eventually I could almost like not have that picture of a cat there, and I could recognize, oh, that's the word cat. So same thing goes here. This is almost like your word cat. So your brain should be picturing some kind of line, some picture of a line in your head. It could look like this. It could be steeper. It could have a negative slope. There's a lot of different things. So just kind of keep that in mind. Okay. So fill in the blanks to complete the sections. A linear function is any function whose graph is a line. Now, some people say a straight line, but remember, every line is straight. So that's like you being redundant. So I'm just going to write the word line. Okay. The graph of any non-vertical line can be represented by an equation in the form of, and you guessed it, y equals mx plus b. Okay. So here's a bunch of things that you should know about it, but just be familiar with y equals mx plus b. Okay. Compare the change in y with the change in x. Okay, so the very first thing is you're going to compare the change in y with the change in x, right? Okay, the next one, we need to find the starting value okay. And then the last one is you're just going to put it all together and write the equation of the line. Okay. So those 3 things, that's really what you're going to be doing in order to find the equation of a line. So the equation that represents Susan's customer service call is shown below. Label each part of the equation with what it represents in Susan's situation. Use 3 phrases: cost per minute times the number of minutes, cost to be connected, and the total cost. Okay, so there's a situation that you might have read in the actual lesson part of it. So when it says cost per minute times the number of minutes, that's this guy here, right? This part's here. And I'm just gonna, instead of writing everything, I'm just gonna highlight it and put it in that section. So this is that part right here. Cost to be connected. Now there was a standard cost that you had to pay just to be connected. And that was this part here. I guess I could highlight this way too. Right? And then the total cost was going to be this. And that's the total cost, right? It's the cost of how many minutes how much it costs per minute, right? That they're going to calculate, and then plus how much it costs just to be connected. That's going to be the total cost when you add them all together. So compare this with the equation y equals mx plus b. Okay, so we're going to compare this with y equals mx plus b. And so I'm going to just encourage you, whenever I have an equation, I'm just going to write it right on top so you can play matching, right? So clearly here you can see who is representing what, right? Because it is literally of that form, that structure. So it says the slope, or m, is y equals to 3x plus 5, right? Is what? Which one is the slope? Well, if you said 3, then you're right. And the starting value, or b, is going to be 5. So name two characteristics of non-vertical lines that make, hold on a second. Name two characteristics of non-vertical lines that make the slope-intercept form a good choice when writing an equation of this type of line. So number one, they're always going to have an m, and they're always going to have a b. So the two characteristics are really your m and your b, right? So using slope-intercept form to graph a linear function. Okay, so whenever we talk about this equation, this is my favorite way to graph a line. I can graph lines on all the other forms that there are, and yes, there are other forms, but this one's my favorite because it's the most straightforward. Okay, so it says the graph of the function y equals 2x plus 1 is a non-vertical line. Vertical means up and down, right? This is a vertical line right here. Okay, follow the steps in the table to graph a new linear function y equals 2x plus 3. Okay, so here it says determine some points of the line. So they want you to substitute x values into the equation and calculate the y values. So they started you off. Plug in 0, what do you get out? 3. Plug in 2, what do you get out? Hopefully you said 7, right? Using order of operations, right? 2 times 2 plus 3 is 4 plus 3. Same thing goes with that next one. I'm going to plug in my 3. And if you've ever watched me plug in stuff, I always like leave an empty parentheses. And then whatever my x value is, that's what I am substituting in there. So what is that? 2 times 3 is 6 plus 3 is 9. So that's going to be my 9. And then I'm going to do it again. 2 times something plus 3. And then I'm going to put that 4 in there. So 2 times 4 is 8 plus 3 is 11. And some of you are saying, hey, I see it, Miss Johnson. I see kind of a pattern right here, 7, 9, 11. And some of you are like, but there's no pattern right here. That's because we skipped a number, right? If we didn't skip a number, you should be able to see a pattern. Then it says plot at least 3 of the points and then draw a line through the points. If your math is correct, they should all lie on the same line because it's a linear function, right? Okay, so I'm just going to graph these points. And in case you forgot the way you graph, this number tells you where do I go right and left. And this one tells me how far to go up and down. So the first point is don't go left and right, go up 3. Okay, so make a dot right there. Perfect. The next one is 2, 7, right? So that says go 2 to the right and then go up 7. So 2 and then up 7. Already, after this point shows up, you can kind of see a line, right? So if the rest of these points don't line up on that line, I must have done something wrong, right? Next point is 3, 9. Does that still look like that same line? Yeah, it does, right? And then the last but not least is 4, 11. And then some people are saying it only asked you to do 3. 4 is not going to hurt you. So let's see. If your math is correct, they should all lie on the same line. And you can kind of see that. And I'm going to try to draw a straight line in there. Look at me. Okay. So I drew a line as best as I could. If you're at home, you're going to probably want to use a ruler to make it a straight line, as straight as possible. This one says calculate the slope of the line, and then it says choose any 2 points on the line and then calculate the slope. So when they say calculate this slope, they want you to use that equation, but you can also count it from the equation, the graph itself. But because they told me to do this, I'm going to calculate it. So I'm going to use the last 2 points, 3, 9 and 4, 11. So that would be 11 and then 4. And then my other point would be 9 and 3. And so my answer is 2 over 1, which is just 2, which makes sense, right? Because this slope here is the same as this slope here, right? This slope here is the same as this slope here, which some of you are even saying, oh, I wonder if it's that slope there. That's a good question, right? And then I want to make sure that it's actually here on my graph. And so if you remember how to find the slope of a line, you pick a point, you take the elevator up. I went up 2 spaces, so that's +2, and I went 1 space to the right, so that's +1. M equals to rise over run, so it's 2 over 1, which is the same as 2 over 1, which is the same as 2 over 1, right? So there's all the different ways that you do this, and you're checking your answer as you go, right? The next little part says, which statements correctly describe the y-intercept? Circle all that apply. The y-intercept of a function is where the point where the line intersects the y-axis. So yeah, that's true. So that's true. I'm going to highlight that. The next one says the y-intercept of a function is the point where x is equal to 0. Let me see. Yeah, that's that point right there. X is equal to 0. So that's true too. And the last little part says the y value of the y-intercept is the same as the starting value b. Is that true? So that's 3 for the y value. Hey, that's 3 right there, and that's 3 right there. Yeah, that's the same. So hopefully you guys all see that. And maybe I should have highlighted in a different color. Let me highlight in a different color really quick, just so I can highlight that on the, so these are all true, right? And if you notice, this point here is the same as this point here, which is the same as that there, okay? So there's the 2 pieces, and you need 2, it's almost like you're making something or you're baking something, and you need 2 ingredients to build this equation. You need your slope and you need your y-intercept. Look again at your graph from question 5. What is the y-intercept? Look again at your graph from question 5. What is the y-intercept? Well, the y-intercept is right there at 0, 3. So we, different people label the intercept differently. I like to label my intercept as a point because it is a point. So I write it as 0, 3, where 3 is my b. Okay. Then it says, in your own words, explain why you think that y equals mx plus b is called the slope-intercept form. So hopefully you see why it's called the slope-intercept form, because like I said earlier, it's the 2 ingredients that you need in order to build this equation. You need the slope. Here's the slope. Here's the slope. And you need the intercept. Here's the intercept. Here's the intercept. Here's the intercept. Here's the intercept, right? All right, next little part. Complete the sentences to show how to find values of y-intercept from the table of values. It says the slope or rate of change is the difference of the y values in the table divided by the x values. It's the y values over the x values. To find the y-intercept from the table, find the input pair where x is equal to what? Where was that y-intercept in our table? Where is it? Oh, it's right there. When x is 0. When x is 0. Okay. If the y-intercept is not in the table, extend the table or pattern so that the table now includes an input-output where x is equal to 0. And if you can remember this is something that I consistently ask my integrated 1 students to do, like, oh man, if only I had where x is equal to 0. And then they remind themselves, oh, we could just go backwards on the table or go whatever, wherever the table is, right? Okay, find the slope and the y-intercept of the functions in the table below. The slope is what? What would our slope be here? Well, according to this, it's, oh, I forgot to circle this and take the corresponding y value. Okay, so here, according to this, we're supposed to take the difference of the y's. Okay, so subtract the y's, sure. So what is that? From 1 to get to -9, that's -10. So subtract them. So I just, oh, wait, I'm subtracting. So I should go, sorry, I did math too quickly. I should do 1 minus -9, which is 10. So I did that. And then it says divided by the differences of the corresponding x. Okay, so then divide by this. Yeah, so 0 minus 5 is -5, right? So then I would get 10 divided by -5, which is -2. And that's what my slope is. My slope is this minus this divided by this minus this, and then dividing, and then I got -2. The y-intercept from a table, find the input-output pair where x is equal to 0, this guy, and take the corresponding y value, this guy, Okay, remember I told you this is a 2-ingredient cake or whatever, right? Have you ever seen those YouTube videos and they're like, you can make a cake in 2 ingredients, right? So here's the 2 ingredients that you would need in order to build that equation, right? Okay, same thing goes here. I'm going to have you pause it and then figure this out and see if you're right. Okay, now that you're back, again, I'm going to just subtract. And I'm going to subtract the same way that I just did. So 16 take away 7, that's 9. And then -3, don't get distracted by this, the negatives, okay? Just follow along. You're subtracting this minus it. It's almost like if I put a big old subtraction sign there, right? So -3 minus -2 is -1. So my slope for this one is going to be 9 divided by -1. Which is just -9, okay? In your head, for those of you who are understanding this a little bit more, you should be looking at the slope being like, oh, I can imagine what the slope looks like, right? For 2 points, because that's a negative slope, right? That negative slope going down this way, right? And it's pretty steep. And then my y-intercept is, let's see, y-intercept is from the table from the input output where x is equal to 0. Uh-oh, I didn't get a 0. So what I want to do is I'm going to put a 0. Oh, a 0 would fit perfectly right here, right? It would fit perfectly right here. So if I go this way, -3, -2, -1, 0. So if you notice this pattern, right, it's going down by 9. Down by 9. So if I go -2 minus 9, that would give me -11. And so that's what my y value right there would be. So that's my intercept, -11. Okay, so then it says circle the correct words to compare the linear and nonlinear functions. A linear function looks like a line on a graph. It's a line. It can or cannot be written of the form y equals mx plus b. It can be. A nonlinear function looks like a curve, and it can't be written as y equals mx plus b. It has a totally different structure. Okay, it'll have a totally different structure. So here they say circle the equation that is a linear function. So I'm looking for y equals mx plus b. Do you look like y equals mx plus b? No. Do you look like y equals mx plus b? Y equals mx. Ms. Johnson, isn't it supposed to be a plus? Yeah, but I could rewrite this so it says plus -1 and it's still the same thing, right? These it plus -1 and subtract 1, it's still the same thing. So yeah, this is correct, right? Y equals 2x squared plus 3. You didn't say anything about squared, Miss Johnson. That's right, because that's not a linear function. And y equals to 5x plus 2x cubed. Miss Johnson, you didn't say anything about that. Yeah, that's right. You didn't. Okay. Given a table of values, you can graph a function. Complete the table to identify the points you should plot on the linear function. So it says -3, -11. There's the point. You're just going to put these all together. Okay. I'm going to have you do that. Fill in the blanks to show how you can identify a nonlinear function from an equation. Okay. Okay. Okay, so use the equation to generate y values. Oops, I am still in highlighter mode. Hold on. For several x values. So basically, I want a table. List these points in a table of values. Plot at least 3 points on the graph to see if they make a line. Right? If the graph is not a line, then the function is non-linear. Okay. If it's a line, then it's linear. If it's not, then it's not. All right. All right. And that's it. Have a great day.